Hello everyone and welcome back to BePharmawise. In today's video, we are going to discuss everything about significant figures. Now, what are significant figures? Let's first understand that. See, we have digits. We have 10 digits. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the digits. When I use a digit alone or in combination with other digit, these digits serve to express a number, right? Now, what are significant figures? These are the number of digits which are actually necessary to express the results or values with certainty. Plus one uncertain digit can be there, which we can refer as plus minus 1, right? So if I want to tell a result with certainty, how many number of digits will I require? That number is referred as significant figures. Now, why significant figures are important? What is the role of significant figures? I will tell you. Suppose I am having a sample and I want to weigh the sample. I will weigh the same sample on, say, a rough balance or on an analytical balance. Now, I got the answers. For rough balance, the sample weighed 15.6 grams, for example. And on analytical balance, my same sample weighed 15.5998 grams. Can you spot the difference? I have taken the same sample and I have weighed the sample on a rough balance and an analytical balance, and see, in my results the number of digits are different. Here I can see 3 digits, here I can see 6 digits. So when the significant figures are with us, we can actually tell the accuracy of the measurement or the precision of the instrument on which it is weighed or measured, right? So in general, if a sample is weighed or a result is calculated with more number of significant figures, it is going to be more accurate and the instrument is going to be more precise. Now, as we know what are significant figures now, let's find out how to calculate the number of significant figures or the significant figures in the given number. So, there are certain set of rules and we have to follow those rules. Rule number 1. Decimal point placement is not considered. Our significant figures are going to be independent of decimal point placement. For example, I am having these figures 515, 5.15 and 51.5. Now when we look at these figures, we may feel that all these figures are different. Yes, they are. But when we are deciding the significant figures, we should not consider the decimal point. So, how many digits we can see here? In this number, there are 3 digits. Even in this number, there are 3 digits. And even in this number, there are 3 digits. So, all these 3 numbers contain 3 significant figures. So, this is the first and very important rule, that our significant figures are independent of decimal point placement. Second rule. Now this second rule is again very important. This states that all the non-zero digits are significant. Suppose I am having this number 127.43. Now all these are non-zero digits. So all the non-zero digits are going to be significant. So in this number there are 5 significant figures, right? I'll take another example, 635.4. All are non-zero digits, so there are going to be 4 significant figures. So we have seen 2 rules. Rule number 1, that significant figures are independent of decimal point placement. Rule number 2, all non-zero digits are significant. Now let's turn to rule number 3. Now we are going to talk about zeros, because we will encounter zeros many times in the numbers. So I will give you 3-4 scenarios. That the first scenario, if I have zeros between two non-zero digits, then I will consider those zeros significant. I'll give you an example. I am having 1, 2, 0, 3, 4. This is a number I am having. Now observe where the 0 is located. It is located between the two non-zero digits. Let me give you another example. 5, 4, 0, 0, 0, 3. Here there are 3 zeros which are located in between two non-zero digits. In such cases, we have to count the zeros as significant figures. So how many significant figures this number will have? 1, 2, 3, 4 and 5. So 5 significant figures. Here 1, 2, 3, 4, 5 and 6. So 6 significant figures. So about zeros, the first rule is the zeros which are placed between two non-zero digits are significant. Why? Because these zeros actually indicate some quantity in place. They have some quantity to their placement. So they are significant. So we are going to count them when we are counting the significant figures. Now let's talk about zeros which are present at the left side, on the left side of the non-zero digit. So suppose I am having 0.00432. Now look at the number. Now here my zeros are on the left side of the first non-zero digit. Now they are not serving a purpose of quantity, but they are serving a purpose of locating the decimal point. So in that case, these zeros will not be considered as significant figures. So in this figure, in this number, there will be only 3 significant figures, this and this. These zeros will not be considered, right? So all the zeros which are on the left side, example 00321. Now here also these zeros are on the left side of non-zero digit. So we will be having only 3 significant figures here. These zeros will not be counted. Another example 0.005. Now here again these zeros are on the left side of first non-zero digit. So they will not be counted. Only 1 significant figure will be counted for this. So rule number 2 for the zeros is, if your zeros are on the left side of non-zero digits, they will not be counted. They are not significant. Now let's move further. If I have zeros like 0. Or let's take 3.210. Now here zeros are not towards the left. Here they are terminal. Here they are present on the right side of non-zero digit, and they are placed on the right side of decimal point. Then they will be considered significant. So in that case 1, 2, 3 and 4. 4 significant figures will be there. Okay, are you getting it? So when the zeros are on the left side, they are non-significant. But when they are on the right side of decimal point, then they are significant. Another example 1.23000. How many significant figures? 1, 2, 3. 4, 5, 6. These 3 zeros will be significant because they are placed on the right side of decimal point. So 6 significant figures will be there. Now let me tell you one more rule. I am talking about terminal zeros. So it may happen that I have a figure like 400. Here also zeros are terminal, right? But they are not significant. If there is no decimal point, if the zeros are not on the right side of decimal point, they will not be considered. So in this case, when there is no decimal point, this 400 has only 1 significant figure. Suppose I am having 5000 as a number. How many significant figures it will have? There is no decimal point. So these 3 zeros become non-significant. So there will be only one significant figure. Now why is this so? You must be wondering why we are not counting these zeros, right? So the reason is these zeros or 400, 5000, these are the values which are measured on an instrument having least count of 1 gram. When we are talking about least counts, the instruments have least count which is always expressed in decimal points. I'll tell you one example. Suppose I am having 400 gram of sample and I am having 0.400 gram of sample measured on 2 particular instruments. Then looking at the figures, I can tell that this sample is being measured on an instrument having a least count of 1 gram. But this is measured on an instrument having least count of 0.001 gram. So that is why when we are talking about decimal points, the least counts of instruments come into picture and it becomes necessary to count the zeros on the right side of decimal point. But when there are no decimal points, the zeros will not be significant. I hope you are understanding, right? Okay, so we have talked about zeros. I will revise briefly. First, the zeros between the non-zero digits are significant. If the zeros are on the left side of non-zero digit, they are not significant. If the zeros are on the right side of decimal point, they will be significant. And if there is no terminal point, zeros are not significant. So this is all about zeros. Now one more rule is there, and that rule states that if we are writing the numbers in scientific notation, then all the digits which are there in the scientific notation will be significant. So if I am having a number 1.234 into 10 raised to minus 5 or 2.303 into 10 raised to 2, forget about this. Count all the digits in this number. So 1, 2, 3, 4. 1, 2, 3, 4. So it contains 4 significant figures. It also contains 4 significant figures. Now I have told you all the set of rules which we are going to use to determine the significant figures. I am going to enlist all these rules in the description box below. You just check it out. So I will briefly revise. First, significant figures are independent of decimal point placement. Second, all non-zero digits are going to be significant. Now talking about zeros, if the zeros are placed between non-zero digits, they are significant. If they are on the left side of non-zero digit, not significant. On the right side of non-zero digit and there is decimal point and they are at the right side of decimal point, they are significant. If they are terminal, they are at the end of the number but there is no decimal point, they are not significant. And then if you are writing the number in the scientific notation, then all the digits present over here are significant figures. Now we have understood how to write the significant figures, but wait, there is one more important point I want to discuss. Suppose we are doing addition, subtraction, multiplication or division of these numbers, of these say numbers. Let us take example of a multiplication. 4.1 into 3.25. I have to multiply these two. Now how I will do? I will just use a calculator and I will do 4.1 into 3.25. My answer comes 13.325. Now look at the numerical given here. This particular number has how many significant figures? 2 significant figures. This number has 3 significant figures and this number has 5 significant figures. So we cannot keep the result in 5 significant figures. Why? Because our result cannot be more accurate than the least accurately known number in the given problem. Now this is my problem. I have to multiply these two, and there are two numbers, and least accurately known number means having least significant figures is this 4.1. So my result will also contain two significant figures, right? So at the moment there are 5 significant figures. I have to round off this number to 2 significant figures. So we are talking about rounding off, right? So I'm having a number with 5 significant figure, and I have to narrow it down. I have to round it off to 2 digits, 2 significant figures. And how I will do? We should start from left and will go towards right. So the first digit I will keep 3. The second digit I will keep, first digit I will keep 1. Second digit I will keep 3. My 2 digits are over. But the last digit will be determined by the next digit in picture. How? If the next digit is 0, 1, 2, 3 or 4 less than 5, then I will keep this digit same. 3 will remain 3. But if my next digit is more than 5 or 5, it is 5 or 6, 7, 8, 9, then I have to add 1 in this number. So in this case, I am going to round off this 5 digit number to this 2 digit number. Let's take another example. Suppose 5.72 is multiplied by say 13.123. Now this contains 3 significant figures and this contains 5 significant figures. So who is having the least significant figures? This number. So my result will also have 3 significant figures. Okay, so I will do this. 5.72 into 13.123. So the answer comes 75.06356. Now this is the answer. Now it contains 1, 2, 3, 4, 5, 6, 7 digits. I have to narrow it down to 3 digits because my least accurate measurement or least accurate number is this. It contains least number of significant figures. So my result will also contain those many digits of significant figures. So if I want to narrow 7 to 3, then I will have 7 as it is, 5 as it is, decimal point as it is, and for 0, what I will do, if I want to retain 0 or increase it to 1 will be decided by the next digit. Now it is 6, so it is more than 5, so we have to add 1 to this number. So 0 plus 1 becomes 1. So I will round off this number to 75.1. This is how we are going to round off the answers of addition, subtraction, multiplication, division, etc. So we have seen how to figure out significant figures, and we have also seen how to round off the answers to the given number of significant figures. I hope you have understood. Let's solve some examples and then we'll stop. Okay, let me give you some examples. We'll solve them together. The first example, let us take 0.007. Tell me the answer. Now here all the zeros are on the left side of non-zero digit, so they are non-significant, so answer will be 1. Only 7 will be counted. Now let's take an example 12005. Here the zeros are between 2 non-zero digits, so 1, 2, 3, 4 and 5. Next 3. Let's take 1.00 into 10 raised to 2. Now look at the number. It is written in scientific notation, so we have to count all the digits. So 1, 2 and 3. It is going to be my significant figure. Then next I am having 1.2300. Now here zeros are on the right side of decimal point, so they are significant. So 1, 2, 3, 4 and 5. There will be 5. Then I have 320075.120. Now see, there are two types of zeros. These zeros are in between two non-zero digits, and it is a terminal zero, but it is present on the right side of decimal point. So we have to calculate all of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 significant figures will be there. I hope you are understanding. Now let's round off some of the examples. Okay. So tell me 123.4. This is the number. I want to round it off to 3 significant figures. What I will do? I will keep 1, 2, 3, and 3 will be decided by 4. Now 4 is less than 5, so I will keep 3. So this will be my answer, rounded off to 3 significant figures. Another example, suppose I am having 56.78 and I have to round it off to 2 digits. Then how I will do? What are the 2 digits? 5 and 6. So what we will do about 6? It will be decided by 7. 7 is more than 5. So we have to add 1 in 6. So it becomes 57. So this is my rounding off for this number for 2 digits or 2 significant figures. I hope you're understanding. Okay. So this is all about significant figures and rounding off. So if you like the video, don't forget to like the video, share it with your friends, and keep watching BePharmawise. Subscribe, press the notification bell, and keep watching BePharmawise. Just take care. I'll see you in the next video. Till then, you take care. Bye bye.